So our class for today is still on networking, but this time we want to try another format to which we'll be able to network, and we can also constitute the time period for the project. A very simple, or rather a project that doesn't constitute so many activities. I've chosen just a small project. Okay, it could be huge depending on what we are covering, but we have got just a few activities here. So maybe we can remind ourselves on how to draw this, maybe using the format activities on the arrows. Just like a summary of what we have been doing all along. Then activity A begins the project. Which, as you can see, it's becoming predecessors of two activities, the activities B and C. Now we have to introduce a dummy here, reason. The activities A and B are starting at the same node here. They are not supposed to end at the same point. And because they are acting as the predecessors of another activity, the two of them, we have to be careful on how now to determine this combination. Because neither of the B or the C are becoming predecessors of other activities all alone, then the dummy can go whichever the direction you want. You can point the dummy towards the C or towards the B. Since, I repeat, because the C and the B themselves alone are not becoming predecessors of other activity thereafter. But if, for example, because I remember there's somebody who had asked about the dummy, if, for example, B alone was to become, let's say, a predecessor of another activity here, we cannot point the dummy towards the B. Again, if assuming C alone was to act as a predecessor of another activity, then we couldn't be joining the dummy towards the C. But because here it's open, whichever the direction you go by will be okay. For example, I will opt to go by with the dummy pointing towards C. But in this case, you can also have it towards B. It will still be okay. The time for a dummy, we said it's always equivalent to 0. Remember, this is not a real activity, just to help us to have a connection of the activities and to understand that flow on how activities are flowing from one, or rather from the start to the end of the project. And of course, we have the activity D there, which again is becoming the predecessor of the final activity, which is E, as we mark the end of our project. Avoid the loops. All the times your arrow should be pointing forward and not backwards. And there we mark the end of our project. Our network is not complete, as you can see. Why? We need to come back and fill in the project's or activities duration. For activity A, we have 4 weeks. B, we have 3. C, we have 5. D, we have 2. E, we have 7. Then again, we need to fill in the earliest event times and the latest event times. So I'll start with activity A guiding us. Remember the start of the project, the first event here should always start with a 0 time because we haven't consumed any amount of time. I'll start with the activity A here to be able to understand what will be the earliest event time for event number 2, or the earliest that we can finish activity A. So we'll have 0 plus 4, this will give us 4, only one arrow, meaning no comparison is required there. Again, here we have only one arrow, so we'll take 4 plus 3, we'll have 7. But for this node number 4, we have got 2 arrows pointing towards it. You can see the one on the dummy and the one alongside activity C. So we'll take 7 plus 0, it will give us 7. Then if I were to take 4 plus 5, it will give me 9. Between 7 and 9, 9 is the larger figure. We go for that. Remember, as we are moving forward, using the forward pass, we are using the largest cumulative value. So you pick the larger figure. In any case, you reach to a point of comparison. Then alongside activity D, I have got only one arrow. I'll take 9 plus 2. This will give us 11. And then, of course, we take 11 plus 7. This will give us 18. 18 is the project duration, the earliest that we can finish, and so the latest that we can finish that activity to mark the end of the event, marking the end of the project. We go backward using the backward pass. In this case, we are taking the smallest cumulative value, moving from an event. So if we reach to a point of comparison, we need to pick the smallest figure or the smaller value. So we are subtracting this time. 18 minus 7, this will give us 11. Here again, I have got only one arrow coming from this circle, number 4. So as I move into it, and remember backwards, I'll take 11 minus 2, this will give me 9. Then here I have got only one arrow again, 9 minus 0 is 9. Then moving backwards to point number 2, we have got 2 directions to follow, so we do a comparison. 9 minus 3, this will give us 6. Then 9 minus 5, it will give us 4. 4 is smaller than 6, we go for that. And lastly, 4 minus 4, this will give us a 0. And if we don't get a 0 there, something actually is not okay. You should go back and do some corrections to your work. Okay, again, we need to come and we mark our critical path. There are 2 ways into which we talked about identification of the critical path. Yeah, if you have filled in this already, then you just check on the path whose events alongside that path have got the earliest and the latest being the same. The upper figure here is the one we call the earliest event time, the latest event time. So if they are the same, such a node should fall along what we are calling the critical path. So I'll have path A, C, D, E. And you can label that as your critical path. You can use hyphens in between or commas as you mark your critical path. The question is, this path will take us how long? We have got 18 weeks, and 18 weeks qualifies to be our project's duration. 18 weeks there, which becomes the project duration, meaning we are able to tell how long that particular project will take following our critical path. 18 weeks. And you have to be very careful as you identify these nodes, because sometimes you might find, assuming here I had a 7, 7, it would mean the node is having the earliest and the latest being the same. However, you should be able to tell which path is actually going to give you the longest amount, the highest amount of time. And in this case, you want to identify the critical path. Remember, we said it's believed to be the shortest route, but given by the longest time. It takes the longest for you to complete those activities you're calling critical. And in any case, you delay any of the critical activities, remember we said the overall project will also be delayed. So this is our critical path. The other method you could have done is you identify all the paths in your project, and of course you pick the one that will emerge to have the highest amount of time. So in this case, we have got how many paths? We have path A, and when you're evaluating the paths, it's important you start from there, top to bottom or bottom to top, so that you don't miss any. You might miss the one that is critical actually. Path A, B through the dummy, D, E. How long is this going to take us? This is going to take us, we count the amount of time by each and every activity in the path. A has 4, B3 that is 7, 9, and you'll have 16. The other path is path A, C, D, E. There's no other path whose duration we had already identified to be 18. So we would have made a comparison between this path and this other path, and would realize that the 18 being the longest amount of time, it would give us the definition of the critical path. So there are those two ways. If you fill in the notes, you just come and mark the path that you see. The notes are having the earliest and the latest time being the same. And then from here, one should be able to compute the frauds as we had demonstrated in our last class. The most important fraud, we said a fraud is the amount of space time that an activity can be delayed, but it depends on that delay will cause what in the project, okay? The most important type of fraud is what we call the total fraud, because the total fraud tells us the amount of time into which an activity can be delayed without affecting the overall completion time of the project. Okay, so this was not our today's coverage, but I wanted us to use it as an example to make a quick summary of what we have already done. And I want us to compare this particular method of drawing the network diagram with the activities on the arrows, with now having the activities drawn on the node. So how do we draw the network with the activities on the node? Let us first of all understand how our node should look like when you're drawing a network with the activities on the node. You can use a big circle, but a rectangle works well in this case because you want to separate it into some portions. What I'm going to fill in here should actually the amount of time to which the activity can earliest start. The earliest start of that activity, just as we were labeling here, the earliest that A would start is at 0 time. The earliest that it could finish is at 4. So the earliest start time, and of course the latest start time. Then here we are going to fill in the areas that that activity can be finished. So I'll not write the full words because of the space. So there you can note this on your book. The area start time, the first portion of our rectangle, the latest start time. And these are the figures that we had already indicated on our circles. The earliest that A would start is at 0 there, latest that it would start it at 0 time. The earliest that we can finish the activity is at 4 weeks, and the latest that we can still finish the activity is at 4 weeks. So I'll call it the LFT. Then what do I fill in at the middle portion of my rectangle? Here I'm going to talk of the name of the activity, name, and on the lower end, I'll talk of the duration. You can write the word duration in full if you're drawing this. So the upper portion will fill in the activity name, like what we have A, B, C, D. Then on the lower end, we'll be filling the duration of the activity. So we can now draw our network, having known on what to fill in. And now the earliest start time, the latest start time, the earliest finish, and the latest finish will be triggered by how is a flow in our network diagram. For example, an example here, as we evaluate the areas to which the first activity would start, of course, it would be at 0 time. And then the latest to which we can finish that, or the areas that we can finish, will be given by considering the amount of duration that is given, the amount of time given for that particular activity in question. And then we'll also still use the forward pass and the backward pass. In any case, we are talking of the forward pass. We are picking the areas that is going to be given, for example, by the largest cumulative value. When you're talking of the backward pass, we are talking of the, for example, the latest to which that amount of time will be given by the smallest cumulative value moving from that particular node. So let's start as we draw our network. The activity starting off our project is activity A. Some people say that this method is difficult, but with practice, actually, it's even easier than what we have already done. Activity A here, with its duration from the project, equivalent to 4 weeks. Then activity A becomes the predecessor of activity B and C. It's important that you network first before you fill in the nodes, the duration of the earliest and the latest. I'm guided by the project, remember. The duration for activity B was 3 weeks. Then A was also a predecessor of activity C. And hope you are following. Are we together? Somebody can confirm.
Yes, we are following.
You know these drawings. But don't worry, once we are done with the first topic, the others are not going to involve a lot of drawings. So activity C has 5. I'm still guided by the project. Then activity B and C, now you can see they are not starting at the same point. They have been separated. So you can now merge the two. They were acting as predecessors of activity D, the two of them. And because they have been broken by these two arrows, now you can bring them together. There's no need of the dummy here. Actually, you realize that whenever you're drawing on the nodes, you not need the dummies. So activity B and C becomes the predecessors of activity D, where D has an amount of time of 2 weeks. And of course, after D, we now complete our project with activity E. So here we have activity E, whose duration is 7 weeks. Okay. Now we need to come back and we fill in our notes. As you can see, there is no amount of time given for the notes. The earliest start, the latest start, like that. We need to fill in that particular part for each and every activity in our project. Okay. And of course, we are using the forward and the backward pass as we do this. So let me pick a different color. So the areas to which you can start activity A, of course, it's at 0 time. We haven't consumed any amount of time. Remember, it's at the beginning of the project. Then class, follow me. I'll take this 0 and I'll add the amount of time for A, which is 4, meaning the earliest that we can finish activity A is at 4 weeks. Then I'm going to push, because B has the predecessor being activity A, so the areas that we can finish A, the areas that we can start B, because B depends on A. So I'm going to push this 4 towards B. And the same to which the C has the predecessor being activity A. So the areas that we have finished activity A, the areas that C can start. I'll push it here. If for anything you reach to a point of comparison, then you're supposed to pick the largest figure. But here we didn't have any comparison. We had only one arrow leading to that particular activity or leading to the node, meaning you need not to have any comparison. Then if B can earliest start at 4 weeks and it's going to take us 3 weeks, the earliest that we can finish it should be 7 weeks. How have I gotten my 7? I've taken 4 and I've added to 3, giving me 7 weeks. How about C? The earliest that we have started C is at 4 weeks. It's going to take us 5 weeks. So the earliest that we can finish that should be 9 weeks. I've taken 4, I've added to 5, giving me 9 weeks. Okay, now D class depends on both B and C. Predecessors of D were both B and C, meaning the earliest that we can start D should be the longest amount of time that any one of these two activities has taken. I repeat, because D depends on both B and C. In other words, or in a shorter way, let me say this. As much as we have completed B at 7 weeks, D has to wait for C to be completed at 9 weeks, meaning we'll only be able to start the D after the C has been completed. C is a determinant of the D, for it to commence. In another way, shorter way, maybe I would say for any point of comparison you reach to, push the largest value that you'll have as you make your comparison. Between 7 and 9, 9 will be our largest figure. We go for it. B has to wait for C no matter how we'll have completed B before. Okay. Then D has earliest started at 9 weeks. It's going to take us 2 weeks. So this will end at 11 weeks. And then because E is depending on D, of course, it has to wait for D to be completed. And the earliest that we have completed D or finished D is at 11, becoming the earliest that we can be able to start our E. And then you take the amount of time taken by E, which is 7 weeks here. You can see we add it to the earliest that it has begun. And you can see now we have the project duration, or rather the time we have completed, E being the last activity in the project. We already have the project duration at 18 weeks. And you can see we are conforming to the other method. They should go hand in hand. The only difference is the style to which you use as you're representing a network diagram. The earliest that we have finished activity E, marking the end of the project, of course, being the 18 weeks, should be the latest finished time also for the same activity. And it becomes the project duration that we have as our 18 weeks. We are now moving backwards, class. We're using the backward pass. We take 18 minus 7. This will give us 11. No point of comparison is needed there. Then we'll push this 11 backwards. But if for anything you reach to a point of comparison, remember, you should pick the smallest figure. Okay, so 11 minus 2, this will give us 9. Backward pass meaning we are subtracting. Then here again, I have got only one arrow. I'll push it here. And I have only one arrow. I'll push it here. No comparison is needed. Okay, then we'll take 9 minus 5. This will give us 4. 9 minus 3, this will give us 6. A point of comparison, this one here. Between 4 and 6, which one do we push towards activity A? We are using the backward pass. We are picking the smallest figure. So we'll take 4 and 6, we do the comparison, and 4 is a smaller figure. We go for that. Then 4 minus 4 is 0. And if you don't get a 0 here, something is not okay. Then you come and mark your critical path. You mark your critical path for all the nodes whose, look at this, whose earliest start, they are at the latest start, the earliest finish, the latest finish are the same. This part of the, if this part of the rectangle and this part of the rectangle are showing figures which are the same, like you could see 2, 2, 3, 3, and it goes all the way to the end of the project like this, that these two are the same, these two are the same. The earliest start, the latest start, the earliest finish, the latest finish for all the nodes, then such a node will fall under what we call the critical path, and you can now be able to identify the activities which gives you the critical path. For example, for activity A, the earliest start, the latest start, the earliest finish, the latest finish, they are the same, meaning that is part of the critical path. Then for B, the earliest start and the latest start are not the same, so you don't even have to look at the others. You do away with that. For the C, 4, 4, 9, 9, they are the same. D, 9, 9, 11, 11, and E the same. So our critical path would be given by path A through C, through D, and finally at E. And we can label the critical path as path A, C, D, E. How long is going to take us to complete our project? 18 weeks. I repeat, draw a rectangle. You can also do a square, a big square, or even a circle. The only problem when you draw a circle is how do you divide it into those nine, are they 9 or 6? 6 portions. It will look kind of odd. So the rectangle is better, or even a big square, which you can be able to apportion to the 6 elements that you're defining. The middle portion, the upper part should give you the name of the activity in the project. Of course, the lower portion should give you the duration of that activity. The first portion of your rectangle, the upper part, should give you the earliest start time and the earliest, the latest start time of the same activity. On the last portion to the right, the upper part should be indicating the earliest finished time for the activity. And if you have reached to a point of comparison, remember we are picking the largest figure, okay? And then the latest finish time, moving backwards, should be that if you are making a comparison, you pick the smallest figure, or the smaller figure for that matter. Now, from this diagram of ours, having activities on the nodes, is it possible, for example, to determine the total float? I've said this is the most important type of the float. The others are not so important, because this is the one we want to see the implication of it whenever it comes to the overall completion time of the project. So how do we determine the total float of an activity? The total float of an activity can be given by, we have got a number of methods that we can use. Number one, method one on how to get the total float of an activity. I can take this figure here, whichever we are calling the latest start time, and we can subtract this figure upper here that we can call the earliest start time. If an activity is critical, you'd expect the result to be 0. If it's an uncritical, of course you cannot have a 0. Okay. A good example, I've said to determine the total float, which is the most important. The others are not so important to us, but they are also there. The total float can be given by the latest start time minus the earliest start time of an activity. Example, activity A has the latest start of 0 minus the earliest start of 0, giving us an amount of 0. And here you are not subtracting the amount of or the amount of time for the activity. The other method we go on and subtract the duration for the activity, but in this case we are not doing that. We are just taking the latest start time, subtracting the earliest start time. You can as well do method 2, total float of an activity in the project using activities on the nodes, can also be given by the latest finish time minus the earliest finish time. The earliest finish time, the earliest finish time to be subtracted from the latest finish time. Example, for activity A here, 4 minus 4, giving us an amount of 0. Why? The activity was critical. We have got no amount of time that an activity that is critical can be delayed. If you do so, the overall completion time of the project would actually be delayed. Activity B here was not critical. If we were to compute the total float for it, it would be what? 6 minus 4, it will give us 2. Alternatively, the latest finish minus the earliest finish, 7 to be subtracted from 9, this will give us another 2. If it's about activity D here, 990, 1111, 0. E also, it will give us 0 for C here, which also was a critical, would have zeros. Reason, no amount of time that we can delay that activity. And if we do, the overall completion time of the project will also be affected. So that is how, in a very short way, one can be able to determine the network for a particular project, and of course, determination of the earliest and the latest, both the finish as well as the start of a particular activity in the project, as well as determining the amount of time that the project is going to take from the definition of the critical path. Let me pick another illustration. Another example of a project where we can network. Don't know how feasible is that. Can you see it? Will I use another?
You can see it.
It's okay, yeah? Yes. It's too tiny. But let's hope that it will serve the purpose. Okay, let me try another border. I think this is better because it has the editing guide. So I just want us to maybe look at this and we see whether we can draw the network with actually having the activities on the nodes. This one, I think it's feasible enough for you to understand the flow of the project. All the times before you draw, it's important to take time and you understand your project by having an imagination on what comes after what, or which activity follows what. And again, to create that picture in your mind that those activities, you have already connected them. So the activity A starts off the project. It's becoming the predecessor of activities B and C. Once we are done with activity B, we can commence with the D. C is becoming the predecessor of activity E as well as F. D and E will come together at some point to become predecessors of activity G. Then activities F and G are also becoming predecessors of activity H. So how are we going to determine our network? We'll use the activities on the node. Let's try and we see the outcome of it. The amount of time for A is 3 weeks in this case. And then activity A becomes the predecessor of activity B and C. And your arrows still used in your diagram should always point forward, never backwards, because if you do, you'll end up introducing the loops, which means it's like you never complete the project. Avoid that circular movement of the network diagram, okay? Your arrows should be pointing forward all the times. So these are the two activities. Activities B and C, which are depending on A, B and C there. B is going to take an amount of time of 4 weeks. C is going to take an amount of time of 2 weeks. Then activity B becomes the predecessor of activity D. So we have activity D here, whose an amount of time given is 5 weeks. Remember, the direction of the arrow should be forward. Then activity C become the predecessors of activity E and D. No, E and F. I'll choose to direct my sorry for this. Activity C was the predecessor of activity E. Okay, I've chosen to direct my arrow for E closer to the D because D and E will come together at some point. Can make this one bigger kidogo. And when you're networking, like in an exercise maybe given, use a pencil. For me, you can say I can always do the adjustments on my board, but for you, you might draw and then you realize here that you're drawing 20 times. So activity E has 1 week. Then we also have activity C becoming predecessor of activity F. With the time for F being 2 weeks. Then activities D and E were to become predecessors of activity G. Whose duration is 4 weeks. Then of course F and G, giving rise to our last activity in the project. H has got no successor. And so we mark the end of our project. And when you're networking, be patient. Don't be in a hurry to finish the diagram. As you can see, I keep on going back to the project that was given to understand whether I am sticking to the way it's flowing from one activity to another. Keep on going back to that project as many times as possible. Ensure that everything is in order. We can check our activity A was to begin the project. And once it is completed, as you can see, it's becoming predecessors of both activities B and C, meaning B and C depends on A. Then once we have completed activity B, we can do activity D. So D depends on B, or rather D is a predecessor, B is a predecessor of activity B. Then activity C becomes the predecessor of activity E and F. So once we have completed C, we can now begin with the E and F. Activities D and E, they have to be completed for activity G to begin. And then once we have completed activity G and F, we can now do activity H. We now go back and fill in these notes. Remember, our diagram is not complete. The first activity marking the beginning of the project, the areas that it can start it at 0 time, we have not consumed any amount of time. We add that to the amount of time that is going to be taken by A, which in this case, we have got 3 weeks. So we'll take 0 and we add it to 3, giving us 3 weeks. Then here we have got only one arrow. We'll just push these 3 to which should be the areas that B can begin. As we complete our A areas, should be the areas that B can begin, and the same with the C here. Here there's no comparison. We have got only one arrow. So once we get the time to which we are going to complete our B, of course, we'll determine the areas that D can start. So we'll take 3 plus 4, it will give us 7. And of course, we push it to the D that it can areas to begin. The same here, we compute the areas that we can complete the C. 3 plus 2, it will give us 5. Since there's no comparison, I have got only one arrow here. I'll push it to which the E can areas to begin, which is 5 at the 5th week. Here again, I have got only one arrow. We'll push because F was determined by C. C earliest finished at 5 weeks. It should be the earliest that we can start the F at the 5th week. Then for the G, we have got a comparison to make. We need to compute the earliest that we can start that we can finish the D as well as the E. So we start with the D. 7 plus 5, this will give us 12. For E, 5 plus 1, this will give us 6. Then which figure should we push to once the G that it can earliest begin should be given by the longest amount of time taken by any one of these two activities, which were predecessors of activity G. And so I'll push 12. Okay. Then of course here, because of the comparison, we have to fill in these two for the areas that they are going to be finished, and then we do the comparison. 12 plus 4, this will give me 16. The areas that we can finish G. 5 plus 2, this will give us 7. The areas that we can finish F. Between 16 and 7, which one is larger? Of course, 16 is larger. We go for it. We added to 3 the amount of time for H, so H can earliest be completed at 19 weeks. We work backwards. The 19 becoming the project's duration should be the earliest and the latest finish for that particular activity. Also the duration marking the period for our project. 19 minus 3, this will give us 16. Because there's no comparison, we just push that 16 here. We have got only one arrow. The same here. We push the arrow is only one. We push the value of 16. Huh? Then we subtract 16 minus 4. This will give us 12. 16 minus 2. This will give us 14. If I'm not wrong. Then here, there's no comparison. I've got only one arrow. We'll take this 12, we'll push it backwards. The same here, there's no comparison. I'll push that 12 backwards. 12 minus 5, this will give us 7. 12 minus 1, this will give us 11. Here, no comparison is required. We'll push the 7 backwards like that. Here we need to do a comparison because of these two arrows. As you can see, there are two arrows here. So we'll compare as we pick the smallest figure or the smaller figure. 11 and 14. 11 is smaller. We go for it. 7 minus 4, this will be giving us 3. 11 minus 2 will have, is it 9? Yeah. Then 3 and 9, we compare because of these two arrows. Whenever you realize that these are not having more than one arrow, always make a comparison. If using backward pass, then you are taking the smallest or the smaller figure in question. So 3 and 9, 3 is smaller, you go for it. And of course, 3 minus 3, it will give us a 0. And we said if you don't get a 0 here, this is one way to which you can tell whether your workings are in order or not. Make sure you do the correction. Then we identify the critical path, the path that has all the nodes with the earliest start equals to the latest start, the earliest finish equals to the latest finish. Our node A here for activity A, B, D, G, and H fulfill that condition, and therefore this should be the path to follow as we network, should be called our critical path now. We come and call that the critical path. So we can say now the critical path for the project is path A, B, D, G, H. How long is it taking us? 19 weeks to complete the project. And so by definition, all these activities we have defined in our critical path, they are critical activities. Okay. Critical activities, remember, are those activities along the critical path in which they cannot be delayed. If you are going to compute the total fruits for these activities, you find they'll all be zeros. But an uncritical activity, the total fruit we said cannot be zero. For example, activity C here. What is the total fruit for activity C? 9 minus 3 giving us 6. And you can also get it as 11 minus 5 still giving us 6. For activity E here, we have activity C. We have said it's non-critical. E is also a non-critical activity. And of course, activity F would still give us non-zero variance as far as the analysis of the total fruits are concerned, because those activities are actually non-critical activities. Okay. So what I'll do is, for your practice purposes, I will give you an assignment class with 2 projects, and you're going to draw the network using the method that you have studied today, activities on the nodes. Is that okay, class?
Yes.
Okay, let me hear from you, maybe the take for the class as we stop there for today.